Well, hello there folks, I hope you're doing well. In this video we're going to be talking about chapter 8.4, derivatives of logarithmic functions. If you remember last time, we did the derivatives of exponents, specifically exponents, using the natural number e. So this is kind of the sequel to that, because the natural logarithm is what we're going to be mostly using, and the natural logarithm is a logarithm of base e. So let's just start off with our general rule. There is a proof if you want it on page 376, but So the key term. Wow, okay, sorry about that. Let's just try that again. First time of my new job here. Excuse me, sorry about that. Alright, so the derivative with respect to x of ln x, so the natural logarithm, ln stands for, this is the same as log e x, is equal to 1 over x. Just like the derivative of e to the power of x is e to the power of x, the derivative of the natural logarithm of x is kind of similar. It's 1 over x. It's an easy thing. That's why we're using it. Using this information now, let's do the examples. So example number 1, there are two parts, a and b. The first one is y is equal to x times the natural logarithm of x. Well, the derivative with respect to y, derivative of y with respect to x, we're going to be using our chain rule. So it's equal to the first term times the derivative of the second term with respect to x, plus the second term times the derivative of the first term with respect to x. Well, we just found out the derivative of ln x is equal to 1 over x. And the derivative of x is equal to 1. So this is x times 1 over x plus ln x times 1. Well, x divided by x is just equal to 1. And ln x times 1 is just plain old ln x. So that is our answer. 1 plus ln x. Easy enough so far. Hey, we're getting somewhere already. Let's try b then. So for b, we have y is equal to the natural logarithm of x squared plus 2x minus 5. Well, for this one, we're going to want to use the chain rule. And let's make our life easy. And let's just say that is the natural logarithm of u. So let u equal x squared plus 2x minus 5. If you do recall, using the rule like this, our substitution or our chain rule, dy by dx is the same as dy with respect to u times du with respect to x. So we've split it up. We've made our life so much easier. So that is the derivative with respect to u of ln u times the derivative with respect to x of x squared plus 2x minus 5. Hey, breaking it up like that makes it pretty easy. The derivative of ln u is 1 over u. The derivative of x squared plus 2x minus 5 is 2x plus 2 minus 0. So put it all together. That is the same as 2x plus 2 over u, but we've got to replace our u back in, put our u back in. So that is the same as 2x plus 2 divided by x squared plus 2x minus 5. And that's going to be our answer. We could in the textbook they factor out the 2, but it's fine the way it is right there. And that's example number 1. But example number 1 taught us another important thing, another important rule, and that rule is that the derivative with respect to x of ln u, using the chain rule, is the same or is equal to 1 over u times the derivative of u with respect to x. And they have another way of writing it as well, but you can refer to page 377 if you actually want to see that. I don't think it's very helpful. With that, let's move on to example number 2. So example number 2, find the derivative of the function f of x is equal to ln of cosine x. Well, we're going to use our chain rule once again, but since it's just a simple thing right there, a simple u, we don't need to like go all crazy with it. First of all, it's going to be 1 over the inside, so 1 over cos of x, multiplied, and I'll put our rule up here actually. So our rule once again is d by dx of ln u is equal to 1 over u times du dx. So we have 1 over u, and then we need to find the derivative of the inside with respect to x. The derivative of cosine x is negative sine x. So that gives me negative sine x over cosine x. But sine over cos is the same as tan, so this is also equivalent to negative tan x, which is our answer. Though this is an acceptable answer as well. You don't necessarily have to pull out the other derivative. Example number 3 is another chain rule. Once again, you're going to find, just like our exponent ones were all, chain rules, the logarithms are also going to be, for the most part, all chain rules. Can't say for the most part all. They're going to be mostly chain rules. So chain rule, derivative of the outside times the derivative of the inside. Really, this is almost a triple chain rule, but since it's just the ln of plain old x, it makes our life easier. So the derivative of the outside is 4 times ln x to the power of 3. And the derivative of the inside is just plain old 1 over x, because the derivative of ln x is equal to 1 over x. So our simplified version is 4 ln x cubed divided by x. That's it. That's example number 3. We're just burning through these examples, hey? Not so bad. Of course, it's got to get a little more complicated, but it doesn't get too much more complicated, and we are going to cut out a couple of the examples. Example number 4 now. And at this point, it's almost, what are we learning? Are we learning anything new? I don't know. I'll do a few more examples, but if you feel like quitting the video right now, hey, more power to you. I won't judge you for it whatsoever. So we want to find the derivative with respect to x of ln x over root x plus 1. This one's a little more complex, but we're going to, follow the same rule. And just to make it a little easier, say let u equal x over root x plus 1. So the first part here is equal to 1 over u multiplied by the derivative of that guy there. So the derivative with respect to x of x over root x plus 1. So that is equal to 1 over, and I don't really like writing them this way, but here we are, 1 over x plus 1, or x over root x plus 1. And here we have a quotient rule that we're going to be using. So the quotient rule, once again, is the bottom multiplied by the derivative of the top. The derivative of the top is x minus the top multiplied by the derivative of the bottom. So let's just do an aside over there. So x plus 1 to the 1/2. Let's find the derivative with respect to x of that. So that's going to equal 1/2 times x plus 1 to the negative 1/2 times the derivative of the inside, which is just plain old 1. So that gives me 1/2 times the square root of x plus 1, because the negative 1/2 of this is 1 over the square root. So that's right there. So we'll throw that in here now to, sorry, that's not right. 1 divided by 2 root x plus 1, all divided by the bottom squared, so the square root of x plus 1 squared, the square root of something that's, or the square of a square root is just whatever's inside the root, so that's just going to give us x plus 1. Pretty messy there. But that's what we have. So I'm going to rewrite it once again. So I have 1 over a fraction. When I have 1 over the fraction, that is the same as the denominator over the numerator. So this is equivalent to the square root of x plus 1 divided by x. And then I have, once again, root x plus 1, x, really should be x plus 1, I guess, minus x over 2 root x plus 1, all divided by x plus 1. And through the magic of all sorts of simplification and stuff, you will find that this is equivalent to x plus 2 over 2x times x plus 1. Okay? Seems pretty tricky. There is a little trick they give after, though. A second solution, and this is definitely going to be your friend when you're dealing with these kinds of logarithms. If you recall from Math 30, the logarithms have rules. So we can rewrite this logarithm, x over x plus 1, as, so the derivative with respect to x of ln x minus one half, actually, let me not skip a step, minus the logarithm of x plus 1 squared. However, when we take the logarithm of something that is to a power, that power comes right down. So that becomes d with respect to x of ln x minus 2 ln x plus 1, which is significantly easier to do, because that's going to give me, well, I have just plain old ln x. The derivative of ln x is 1 over x. And then I have minus 2. Sorry, that's not 2. This is 1/2 because it's a square root. So, sorry about that. Which is equal to 1 over 2. Now, I'm not going to skip steps. 1 over 2, 1/2, times the derivative of ln x plus 1, which is just plain old 1 over x plus 1. So that simplifies, once again, to 1 over x minus 1 over 2 times x plus 1. There we go. So there's our answer, which, through the magic of, once again, fractions and all sorts of math that you can do, these are actually equivalent. If I want to rationalize my denominator, or not rationalize my denominator, if I want to find a common denominator here, I will get the top But there we go. So these are equivalent. The second way is probably a lot easier for you to find your answer, though. But I thought it was good to show both. Example number 5. Ooh, that's a 5. That's a 5. This one's just teaching one more rule. So the logarithm of the absolute value of x, or the natural logarithm, the ln of absolute value of x. So finding the derivative with respect to x. We have two cases, right? If x is greater than if it's greater than 0, so if it's positive, if x is equal to if x is greater than 0, then the ln of the absolute value of x is equal to ln of x. Either case, if x is less than 0, the absolute value of x is equal to ln times negative x, because our two negatives will make a positive. So the derivative of the first one is just 1 over x. The derivative of our second case, so ln of negative x is equal to 1 over negative x multiplied by the derivative of that, which is negative 1, which is also 1 over x. Therefore, the derivative with respect to x of ln absolute value x is just going to be 1 over x. There is one case, so x cannot equal 0. It's got to either be positive or negative. It can't equal 0. That's the one rule. But there we go. So that's it. A rule worth remembering. In the previous chapter, the previous section, we only dealt with powers that had a natural logarithm as a base. And it turns out, I thought this came later. I thought that was university stuff. But it turns out we can still deal with that if it is not e to the power of something. If it's anything to the power of x, so any variable b to the power of x, using the natural logarithm, we're using this sort of information, the derivative of a number to the power of x is the number to the power of x multiplied by the logarithm of the base. So the derivative of a power, which is a base and an exponent, is equivalent to that power multiplied by the natural logarithm of the base of that power. There's a proof. Feel free to use it if you want. It's on page 379. But don't feel like you have to. So example number 6, let's find, it says find the derivative of y if y is equal to 2 to the power of x squared. Wow, we're just getting crazy here with our double power. So the derivative of y, or y prime, is equal to, well, first of all, it tells us it's b to the x, so 2x squared. Ln of 2. However, we do have a second power here, which means we're going to have to deal with the chain rule. If it were just 2 to the power of x, we'd be done. It'd be 2x, 2 to the power of x times the ln of 2. But since it's 2 to the power of x squared, we also have to multiply it by the derivative with respect to x of x squared. But that's easy enough to do, because the derivative with respect to x of x squared is just 2x. So ln 2 times 2x. And that's it. So 2x squared times the ln of 2 times 2x. And they write it a little bit different in the book, but anyway, so that's it. That's for that part. There's one more rule. So for any exponent, there's our rule. one more rule for any logarithm. So if it's not the natural logarithm, if it's like a base 10 or any other logarithm, we do have one final rule that we can deal with, and this will be the last example that we talk about. So the derivative with respect to x of the logarithm of base b of x is equal to 1 over that x times the natural logarithm of b. Once again, there's a proof, but, be my guest if you want to do that. So let's just check out example 7 and see one example of it. And once again, we're going to be using our chain rule to solve this buddy boy here. So the function with respect to x is equal to log base 10, so I'm not going to write it, log 3x plus 1 to the power of 4. Well, what is f prime? What is the derivative f prime x? First of all, because we have a logarithm to a power, we're going to rewrite this. This is the same as 4 log 3x plus 1. That's the rule, right? There was a proof that we did in Math 30. You can look at your notes, I guess. You probably don't even have the notes anymore, but it's there. It's true. I promise you it's true. So we are going to take the derivative, and we're going to use this rule right here. First of all, 4 here is a constant. We'll just take it out. We won't even worry about it anymore. So 1 over my x, so that's this part here, 3x plus 1, times the natural log of the base. So the base, since it doesn't say anything, is base 10. That's our first step. However, once again, in our x, we do have more than just x, so we have to take the derivative of that too. So derivative with respect to x of the inside, we do have to find or do the chain rule, but it's just 3x plus 1, so the derivative of that is equal to 3, which gives us 4 times 1 over 3x plus 1 ln 10 multiplied by 3. Which simplifies once again, so 3 times 4 is 12. We'll just put that on top. That is the same as 12 over 3x plus 1 ln 10. And that's our answer. And that's as far as we will go with that. So that's it. A few rules that we need to remember, I guess, or keep in mind. The derivative of the natural logarithm of x is 1 over x. The derivative of a slightly more complicated thing, so natural logarithm of some sort of function, is 1 over that function times the derivative of the function with respect to x, or the derivative d by dx of ln u is equal to 1 over u times du dx. The third formula that we learned, I guess, sorry, there was a second formula. The derivative of the absolute value of the ln of x is always going to be 1 over x regardless. And then the third one, the derivative with respect to x of any sort of power, is equal to the power times the logarithm, the natural logarithm of the base. And then finally, the derivative with respect to x of the of any logarithm is equal to 1 over the any logarithm of x is equal to 1 over x times the natural logarithm of the base. So make sure you keep that in mind. Hope this was clear for you. If you have any questions, please do let me know. Hope you have a fantastic day, and I will talk to you later.